Okay, so third technique. Integration using partial fraction decomposition. Okay, so let me start with an example. And once you understand how this example works, we will, I will show you all the cases. Okay, this is not very difficult, it's just long, but it's not difficult. Let's say I'm asking you to find the antiderivative of x minus 1 over x2 plus 3x plus 2. Okay, here's a question. I just made it up right away. Okay, so what can I do here? So what are my options? So we learned substitution, we learned by parts. So definitely there's no by parts here. I don't see a multiplication of two terms. Okay, I see a fraction. And the only thing I can hope for is to do a substitution by taking the denominator as u and hope that the derivative gives me the top, which is not the case. Okay, if you do the derivative of the bottom, you'll get 2x plus 3, and that's not really x minus 1. So
did you factor out the bottom?
Okay.
And you get x plus 2 and x minus x.
X plus 2, x plus 1. Good. Yeah. And then what?
And then you would be able to
what?
Well, you can't do that. I was going to say you factor out a negative from the 1, so you would be able to cancel out the two terms.
No, if you take out a negative, it would be minus x plus 1. You can't cancel.
Exactly.
Okay. But the first step is very correct. The first thing you'll do, and that's the first thing you should notice, is that you could factor the denominator. Okay, so if you could factor the denominator, chances are you will use a partial fraction decomposition, like what I'm going to show you right now. Okay, so let's start with factoring the denominator. So that's x minus 1 over, and this is x plus 1 times x plus 2x. Okay, good. So far so good, but we're still stuck. So let's do the partial fraction decomposition. This is what I'm going to do now, okay? So let's decompose x minus 1 over x plus 1 times x plus 2. Okay. So how do I do this? It's as follows. X minus 1 over x plus 1 x plus 2 is equal to, so I'm going to write this fraction as a sum of two fractions. Okay, the first fraction with a denominator of x plus 1, and the second one with a denominator of x plus 2. Okay, if I add two fractions like this, how do I add fractions? I have to find a common denominator, and I'll end up with the same denominator as here. Okay, I just need to know what are the numerators here. So I'm going to call this A, and I'm going to call this B, and I'm looking for these values. Okay, so Apparently, there's a way to write this fraction as a sum of two simple fractions. And that's what I'm looking for. You with me?
Yes.
Okay, so I'm going to continue up here. X minus 1 over x plus 1 times x plus 2 equals 2. And now I'm going to find the common denominator here. Everything on one big fraction of x plus 1, x plus 2. And how do I find the common denominator? I need to multiply a by what?
X plus 2.
Very good. So it's a times x plus 2 plus, and b times x plus 1. Are you with me?
Yes.
Any questions? Okay. So what do I have here? I have two fractions that have the same denominator now. So that means the numerators have to be the same for all values of x. Okay? So x minus 1 has to equal to a times x plus 2 plus b times x plus 1. And this is for all values of x's. Okay? This means for all. Okay? Listen here very well. Okay. Whatever. Okay. So if it works for every value of x, well, if x is equal to -1, still works. Okay. So let's say x equals -1. What do I have on the left? -2. Here I have -1 plus 2 is 1 times a. And -1 plus 1 is 0. So I just found that a is -2. Okay, that's why I chose -1, by the way, because that will cancel this term. It will cancel this term. Okay, you with me? And now I'm going to take what? X equals what?
-2.
Very good. I take x equals -2 to cancel now this term. And so -2 minus 1 is -3. Equals to, this is 0. And -2 plus 1 is -1 times b, so it's -b. And so I just found that b is equal to 3. Okay, so this is very good news. I just found what a is, and I just found what b is. And so I could now, instead of integrating this complicated term, I could replace this term by a sum of two easy fractions. Okay, so the integral becomes a over x plus 1, so -2 over x plus 1 plus b, which is 3 over x plus 2, all this dx. Now it's easy. I could do a substitution for each one, and I'll be done. Okay, so let me separate it to two integrals. So it's -2 integral of 1 over x plus 1 dx plus 3 integral of 1 over x plus 2 dx. Okay, let me continue here. So for the first one, so I have equals -2 integral 1 over x plus 1 dx plus 3 integral. I'm running out of space now. This doesn't fit. So I'm going to leave this for the substitution. So I'm going to put u is x plus 1, and so du is equal to dx. That's in my first one. So I get -2 integral of 1 over u du. Okay. Which is -2 ln absolute value of u. Okay, and for my second one, will be the same idea. Okay, I'm just running out of space. Sorry. So it's equal to -2 ln of x plus 1 absolute value plus 3 ln of x plus 2 absolute value plus. Okay, and that's my answer. Let's just move back here. See, du is equal to dx. There you go.
Sir,
Yeah.
if you have a linear equation in the bottom and in the denominator and the numerator, would you use the same method?
A linear equation?
Yeah.
No. This works. It's useful when you have a denominator that you could factor.
Okay.
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 Okay, so try this. Integral of, let's say, okay, so this is x of x plus 3 over x2 minus x minus 2. So if I factor this, I will get x minus 2 and x plus 1. A. Okay, and so x plus 3 has to equal to a times x plus 1 plus b times x minus 2. Okay, this is for all x. So let's plug in the value of x. Let's say x is equal to 2. This means that phi is equal to 3a. And so a is pi over 3. And I'm going to plug in x equals -1 now, which means that 2 is equal to -3b. And so b is -2/3. Okay, make with me? That's it. So now this integral becomes a over x minus 2. So 5/3 over x minus 2 plus -2/3 over x plus 1 dx. Pull out the 5/3, so 5/3 integral of 1 over x minus 2 dx. Pull out the negative 2/3, so minus 2/3 integral of 1 over x plus 1 dx. And then we do substitution for each one, and we get ln and ln. And that's my answer.